Hello everyone. I welcome all to this class where we'll study classification task. If you remember, we've already completed the regression task and I introduced a beautiful mathematical function in the last class. That is sigmoid function. With the help of sigmoid function and keras, we'll be able to train a neural network for a classification task. If you attend the class till end, I'm 100% sure you will have no doubt at the end of this class and your ideas will be clear. So see here, I presented another example to the right. The left-hand side table, if you see, that is what I discussed with you last time. And this time, if you see, we have a similar example. However, there is a little change. What is that change? Here, X column, if you see, the values are 20, 30, 80, and 100. Y column, if you see, the values are, I shouldn't say values, the category. Okay. The categories are failed and passed. You can consider the numbers X and Y, the X numbers is the marks in an exam or whatever you want. In this example, I consider someone who appeared an interview recently and we want to know whether she will get the job or not. If you see the image, both are happy. The one job seeker, she appeared an interview, she feels happy. At the same time, the HR is also quite happy with the performance. Both are happy. But if you see, as there is a saying, there is many a slip between the cup and the lip. Now what happens is the salary expectation. Now the HR is asking the candidate what amount you expect. Now when she says an amount, then the HR manager will take a decision whether to give the job or not. Every other thing is over. Okay. So there is a neural network here. I have only one output here. The output is here passed or failed, passed the interview or failed the interview. If you see, this was previously a regression task according to the left hand side data. Okay, that was a regression task. According to the right hand side table data, this is a classification task because my target variable, that is y, the last column, is now a categorical variable. It's no more a number variable, it's a categorical variable, it's not numerical. So what will happen? This will fall into the other types. So here, as I already explained you, we'll divide this one. Division means not like dividing the neuron, we can do that, but here in the diagram we'll divide here. Okay, this is my output neuron and this is my input where I send the data one by one, 20, 30, 80, 100. But then how can we get a number which one will transfer to a category, right? So that's what we'll learn today. Of course, I explained already in the last class. We'll continue it further. Okay, concentrate here. This is not required now, the regression task. So let me take that regression task. So we'll make it a cross. Okay, so this one is no more required because it was a regression task. This is required. So I'll bring this one to this side. Done. And regression task also we don't need. So let me delete this regression task. Okay, done. Now we'll be doing this classification task. Okay, I'll take you through the keras coding, but before that, we'll try to understand through mathematics. Okay, the intuition behind this. So now the training starts. Okay, how we'll train first? Here we'll send 20. Done. And then you will get a number that is called, suppose, y. What is y? There is a linear combination. There is a linear combination between the input and part of output here, not the full output, right? The left hand side. So what is the connection here? Let me write y is equal to a plus bx. We know this one already. Okay, a plus bx. What is my a here? A is my bias and B is my weight, only sole weight, single weight. Now, if you see, this is connected this way. So when I send 20, I'm expecting y now here. So initial values of a and b, these are the random values we'll get. Suppose I start a with 3 and b with 2. Then what will happen? Then what will happen? My y will be equal to, let me write the values, 3 plus b is 2 here and x is 20 here. If you see now, I got a number 43. Now recall, I sincerely request you, if you didn't watch my last video, please go and watch and come back here. There are so many reasons. Main reasons are, you'll understand this properly if you watch the last video. And importantly, there is another reason, you'll also increase my view time. So keep it in mind. Now here, if you remember the sigmoid function, which will do the magic, which will transfer the numbers to categories. I already explained, but then let me once again state the same function here. Let me write it here. The function watch f of x, I'll write f of y here. It's a dummy variable, will not worry. 1 upon 1 plus e power minus y. Now, this y, when you will input here, will get the value z. I say z, okay? So that will be 43. 43. Okay, if you put 43 here, you check it. It will always be greater than 0.5. That I know, because any number, any positive number you get here, any positive number, that will always spit a positive number. Okay, now it's like this. Any positive number you write here in y, it will always give you a number greater than 0.5. But then if you write a negative number here, you will get a number less than 0.5. And as I already mentioned you, the bounds are 0 and 1. These are the upper and lower bounds. It can never go down 0 and it can never be more than 1. And if you get a number here, you say failed. If you get a number here, you say passed. We'll decide whether she will get the job or not. Before that, see, we want to train a neural network where we'll input the data and we'll see whether she will get this job or not. Before that, we are training our neural network with the data. Okay, we have to fix the values of A and B. To fix the values of A and B, we need these. Okay, so first row, now we are trying to see. Unfortunately, you will get P here, whereas in the data, it's failed. In the data, if you see, it's failed. Okay, failed. In the data here, this is failed. 80 is passed here. 100 is passed here. Okay. So this is like this 43. When you get 43, when you find Z here, Z will be equal to, you can check using a calculator, it will be something like 0.8 or 0.7, whatever I can say now. This will be more than 0.5 and this will go here more than 0.5. So we'll term it as pass. But here if you see, in the data, it's failed. So first row is not working. Okay, first row is not working. Then what will happen? Neural network will change the weights and biases, and it will make it sure that this will work properly, not only for the first row, but also for all the rows. So what we'll do here, the neural network will try with, manually also will do here, but the neural network will try to update the weights. The neural network will find weights in such a way that all the rows are satisfied. We are checking one row at a time here. Okay. So the first row we are checking. So what the neural network will do is change this one to, suppose we don't know, minus 30. Okay. Let's try with this. B is 2, A is minus 30. You can change B as well, not a problem. So my A is minus 30 and my B is plus 2 and my X here is in the first row 20. 40 minus 30, again 10. It's not working. It's not working. So what we'll do is we'll increase this. We'll make A 80. Okay, let's try with minus 80. Minus 80 plus 40, that is 40, minus 40, negative. Awesome. Negative means what? When you will write this one here, okay, my z will be 1 plus 1 divided by 1 plus e power minus 40, and that will be something like 0.71 or whatever. It will be more than 0.5, because these are, this is, sorry, this is a negative number. This will be something like 0.21, and this will come this side, and this will be term as failed. And there is a tick mark, first row is trained. Awesome, right? First row is trained. Then we'll go to the second row. You have to input now 30 here. Write 30 here in X. I'm changing. Are you marking? 30. 30 multiplied by 2, 60. 60 minus 80, minus 20. Minus 20 again you put here. Minus 20 when you put here, you will get a, again, number less than 0.5. Double awesome. So here you will get something like minus 0.1, and because, sorry, minus this will be 0.1, and this falls here, so this will be term as failed. Good. So far, so good. Now let's put 80. Okay. If you write 80 here, this will be positive. Oh, it's working for third row as well. 80 multiplied by 2, that is 160 minus 80. Okay, that's positive. And positive means this is passed, right? Done. You can check it. Now put the last one, 100. 100 multiplied by 2, 200. 200 minus 80, that is 120. Positive. Positive means again you will get a number. When you put in y, you will get a number z that will be greater than 0.5. And this is passed. All my rows are satisfied. With this weight and biases, you might be thinking, why I need to use TensorFlow to train them if I can do manually? There are two reasons. One reason now I'm saying, the first reason is, we have only 4 rows of data, right? What will happen when you see 4 lakhs of data? 4 lakh rows. It will be huge. Manually, you will not be able to do that. You have to use a neural network. This is only I'm projecting so that you'll follow it. Okay. Now we'll use a neural network for this. The second reason, I'll tell you. Okay. Once I train, then I will say you the second reason as well. Now you see. This will not take more than 5 minutes for you, because the same thing we have done last time. The same kind of data. No change up to this. Okay. So I run it already. And no worries. I will give these two. You check the link. Okay. You click the link and download these ones, and then you run it. Okay. You should have Google account. That's all. I'll give this in link. No worries. Now, this is the data. So, of course, fail is 0. We have to write number representation, and 1 is passed here, and 20, 30, 80, 100. I put here. Now, if you see, I have one here. This is a new one. Activation is sigmoid. This was not there last time. Okay. And now, here if you see model summary, I have 2 parameters and B, and these will be estimated. Optimizer HGD, last time it was there. The loss was mean square error. And now the loss is binary cross entropy. Don't worry. I will explain what is binary cross entropy later in the next class. No worries. Matrices accuracy. This I will explain in today's class, also in subsequent classes. Okay. Because we'll come across a lot of classification tasks. So let's not worry. Now here is what we'll train. Nothing new here. Okay. Base size 1, 2, 4, whatever you write, you run it. I run it. I took how many epochs? 2000. Just because we have only 4 rows of data, right? It's very tough when your loss will be very less. It will go towards 0.1. Again, I'm saying, if you are seeing for the first time, don't see it for watching. Watch it to learn. And you go to the last video, complete it, then come back here. See, I reduce my loss to point. If you see, it's around 0.02. It's coming down and down. And I hope it will go to 0.01. I don't remember. Let's check. So, lot of still rows are there. Now 962. Okay. Again, I have to go down. No worries. Now it's over here. Okay. 2000. You see, 2000 epochs over. I took 1 row at a time base size. So 1 by 4, 2 by 4, 3 by 4, 4 by 4 for each epoch. But my accuracy is 1. Okay. Accuracy is 1 means it's great. 4 rows. And loss is also, it's 0.02. That will accept, no problem. Now see, The neural network is giving, just remember, 0.149. I will take 0.15 minus 7.8. Remember, okay? Minus 7.8, this is 0.15 I will take. These are my weights and biases. And I will explain you something with these two. Now, new data I've taken 90. Suppose, the question is, suppose the employee will demand 90,000 a month, whether he will get the job or not. Now, HR manager is quite happy to say yes. That is one. One means yes. So she passed now. Let's go back to the board. Now, if you see the board here, what happened? We wanted to predict if she demands 90 here, that is somewhere here, whether she will get the job or not. Now, with 90, it's passed. That means he will get the job. Okay. Now, you might be thinking, with less salary, she might get a job. With more salary, she might not get a job. But it's not everywhere the case. Probably if you ask for 20K, it's a deep learning job, they will doubt about your credibility, right? So that is how the data is. Even I wrote this way because for the neural network has no idea that somebody is appearing an interview and somebody is giving a job. Neural network only understand the numbers. Okay. So what I wanted to say you with this kind of a data is I wanted to demonstrate something. I wanted to show you that the numbers are important for a neural network, not the original X, Y, and the story, right? So according to the pattern was these small numbers, wherever it will find, it will say fail. Whenever it finds bigger numbers, it will say P. That's all, nothing more than that. This is over now. Let's go to the next one. See here, students appear the exam. This is data. Okay, two exams they appeared. I've written E1 and E2 here. If you want, you can say unit test 1, unit test 2. If you want, you can consider as your exam 1, exam 2, or half yearly final exam. Doesn't matter, whatever you think. But ultimately, these will be numbers for the neural network. And when you give the data 5 and 3, okay, when you give the data 5 and 3, the neural network should output a fail. Okay. So here, this is the divider. What will happen is, we'll check now. We'll check what we are getting. So how many parameters will be here? If you train these 4 rows data, okay, if you train the neural network with these 4 rows of data, how many parameters it will estimate for you? Best parameter A, B1, and B2. A, B1, and B2. So randomly, we'll take A, B1, B2, and we'll check one row manually to get the intuition behind this learning, or you can check 2 row at a time. And for that, you need matrix multiplication. So we're checking 1 row at a time here. But the neural network, whatever way you say, that way it will train. Ultimately, it will give you A, B1, and B2 with possible small loss. Again, that small is subjective. Probably I might be fine with 0.01 loss. You might run and try to minimize the loss further. Okay. The coding will remain the same. There is no difference at all. The only difference here is I have 2 input neurons. Okay. And output only 1 neuron. Okay. So output is counted. I have 1 neuron here. There also I had 1 neuron. Here I have 2 inputs. There I had 1 input. That is the only difference. You see, in the coding also, there is only one difference. If you see here, see, I input here all row. Okay, two columns. I have 2 features, 1 target. Here fail means 0, pass means 1. Done. Now go here. Sequential model. See, that time I wrote 2. Here I wrote 1. I wrote 2. That's all. 2 inputs, right? Input step is 2. And again, sigmoid activation, no change. No change at all. Here no change. Here no change. Now for the new data, I put 5, 6. That means due to whatever reason. See, if you see here, okay, she looks quite sad. Due to whatever reason, she didn't appear the exam well. She got the marks 5 and 6. Don't confuse with these 5 and 3. Okay. These are past record. Now, she appeared 5 and 3. And of course, she knows that she will fail. Okay. Probably she was not well. What the neural network says, let's check. If you check here 5, 6, neural network says here, let's go down a bit. We'll get it very soon. Okay. All right. Now, if you go down, finally, we got here. It's all over the training. And then what is my loss? 0.06. It's okay. I tried a lot. I got this. Accuracy is 1. That's great. Okay. Accuracy is 1. Now, again, if it's greater than 0.5, less than binary prediction, it says 0. Of course, 0. She got only 5 and 6. How we think that she will pass? Okay. So don't worry about this. I explained everything in the last class. There is a little change in this class. Even that change also you should run and you have to verify. Okay. You play with the data. Okay. Do something here and there and you implement, because these are the initial stages for you. We are taking only baby steps. Okay. And further, if you see up to 3, 4 classes, we'll go to a very high level. Okay. The difficulty level will not increase. You will have lot more, you will have lot more things to do. That will be the only addition.